Okay, hello guys. This is Akram. Today I'll be presenting the SSH protocol. All right, next slide. Okay, so what is SSH protocol? So SSH protocol, which is also known as Secure Shell or Secure Socket Shell, is a network protocol that gives users, particularly system administrators, a secure way to access a computer over an unsecured network. SSH Secure Shell also refers to the suite of utilities that implement the SSH protocol. Secure Shell provides strong password authentication and public key authentication, as well as encrypted data communications between two computers connecting over an open network such as the Internet. SSH refers to both the cryptographic network protocol and to the suite of utilities that implement the protocol. SSH Secure Shell uses the client server model connecting the Secure Shell client application, which is the end where the session is displayed, with SSH server, which is the end where the session runs. SSH implementation often includes support for application protocols used for terminal emulation or file transfer. Okay, going to the next slide. So continuing off of what SSH protocol is, it also presents in all data centers SSH ships by default with every Unix, Linux, and Mac server. SSH connections have been used to secure many different types of communication between a local machine and a remote host, including secure remote access to resources and remote execution commands, delivery of software patches and updates, and other administrative or management tasks. So it has a lot of use, as you can clearly see. In addition to creating a secure channel between local and remote computers, SSH is used to manage routers, server hardware, virtualization platform, operating system, also, and inside system management and file transfer applications. Okay, going off to the next slide. Okay, so we'll be discussing some of the features that SSH has. So the first feature that SSH has is secure remote access to SSH enabled network system or devices for users, as well as automated process. So the second one is secure and interactive file transfer sessions. Third, automated and secure file transfers. So it's also secure and also automated. Fourth, secure issuance of command on a remote device or system. Fifth, secure management of network infrastructure components. SSH could also be used interactively to enable terminal sessions and should be used instead of the less secure Telnet program. So compared to the Telnet program, obviously SSH is much more secure. SSH is also commonly used in script and other software to enable programs and systems to remotely and securely access data and other resources. Okay, next slide. Go to the next slide. Okay, now we're talking about hardening. So this is the first hardening recommendation I have for SSH. So the first thing you want to do is configure ideal timeout interval. The ideal timeout interval is the amount of time an SSH connection can remain active without any activity. So if you leave it on and like I don't know for 1 minute or 2 minute, 3 minute, however long, you could set a timeout interval. Such ideal sessions are also security risks. It is a good idea to configure ideal timeout interval. The timeout interval is a count in seconds and by default it is 0. So you may change it to 300 for keeping a 5-minute timeout interval. The SSH server will send a live message to the client. If it doesn't get a response, the connection will be closed and the end user be locked out. So the instruction you will put in is client alive interval 300. So 300 is standing for the second. So this would depend on the personal user, because if you're always need more time, like in between times you're like stopping and not working and then you come back working, like if you're doing 10-minute breaks or 5-minute breaks or 3-minute breaks depending on your personal time constraints, you could edit out the ideal timeout interval. But the whole point is the longer the time interval there is that you're not there, the much more riskier it is for like unauthorized users gaining some type of access. So you might want to watch out for that. Also, you just put client alive interval and you edit the number of seconds that you want. So 400 seconds to 600 seconds, depend on your personal stuff. All right, next slide. The second. So this is second hardening is disable X11 forwarding. The X11 or the X display server is the basic framework for the graphic environment. The X11 forwarding allows you to use the GUI application via SSH. Basically, the client runs the GUI application on the server, but thanks to X11 forwarding, a channel is open between the machine and the GUI application is displayed on the client machine. The X11 protocol is not security oriented. If you don't need it, you should disable the X11 forwarding SSH and you would put in X11 forwarding space no. So for us, we don't really need any of the graphic environment to do any of the things that we need to do. So we'll just disable the X11 forwarding. Right. Next hardening. Okay, so this is the third hardening recommendation I have for SSH is to basically set up a two-factor authentication with SSH to take the SSH security to the next level. You may also enable a two-factor authentication. In this approach, you receive a one-time password on your mobile phone, email, or through a third-party authentication app. So it really depends. There's two options you could do with the third-party authentication app, or receiving directly to your phone number or email. And also a lot of the times there is a time limit on your response. Once there is a link sent to your mobile phone or email, if you don't put it in with, let's say, 60 seconds or 120 seconds, then it cancels it. So you would have to request for another chance or another pretty much relog in and try to do it one more time, basically. All right. Next slide. Alright, so this is just a citation that I used for this, and that'll be the end of the presentation. Thank you.